Okay, let's begin. So let's talk about adding, just looking at the denominator and making it a like denominator before we go back and really start adding these two rational expressions. So let me get rid of my cute little picture and talk about our LCM. What is the LCM of A and 3A? 3A. So what would I have to multiply this side by in order to get a common denominator of 3A? I'd have to multiply it by 3 over 3. Would I have to multiply 3A by anything?
No.
No. Good, let's go on to the next one. LCM. What would I have to, oh, I'm getting ahead of myself. What's the LCM of B and B plus 1? We have a quantity of B plus 1. It would be B plus 1 times B. Because isn't this a quantity and isn't this a quantity? And we have to represent both of them. Got it? So if this is my LCM, what would I have to multiply this side by to get a common denominator of B plus 1 times B? B plus 1. And what would I have to multiply this side by to get B plus 1 times B? B. Good. And that would give me a common denominator of B times B plus 1. It doesn't really matter which one I put in front, right? What property tells me it doesn't matter which one I put in front? What property in math? Commutative. Good. All right, let's move on. You need to go back?
That's it?
No. Not even close.
That's what I'm saying.
My biggest concern right now is that you understand how to find a common denominator.
So basically we multiply just like size the LCM. So you know what I'm trying to say.
Yes. Let's do these. What's my LCM of number 3? Does everybody see how these are two different quantities? So we need to represent both of them. What would I have to multiply this side by to get a common denominator? X plus 2 over X plus 2. What about this side? X minus 3. And that would give us a common denominator of X minus 3 times X plus 2. What about this one?
Y minus 2, Y plus 2.
Let's factor this one. Right? It's a perfect square trinomial. If I were to factor this, this would be this factor, y plus 2 times y plus 2. Right? So what's my LCM then? No. There's two of them. If I said one of my denominators was 64 and the other one was 8, wouldn't I have to represent the bigger one? Well, isn't this just 8 squared? So 8 squared would be my LCM, right? You got to make sure there's two of them. So I have to make sure there's two of them. Is there two of them on this side? Yes. So we don't have to multiply this by anything, but we do, however, have to multiply this by what? Y plus 2. Okay, let's talk about that again. So do you see that this one has 2 of these quantities in it? This one only has 1. So we have to multiply by another one so that there's 2 represented. Right?
Okay, yeah. I do.
Got it. It's just like saying this. What if I had these 2? What would you tell me the LCM is? Mm-hmm.
So that's why I wanted to.
See it?
Like, I knew it was in the beginning.
Oh, yeah, that's why I wanted to say it again. Make sense now? Okay. All right. So that would give us a common denominator of y plus 2 squared. Are we ready to go on? Yes, Connor. Any other questions? Okay. What about these? All right, so what is my LCM of these?
H plus 2 squared times
H plus 2 squared times H minus 2 is exactly correct. What would I have to multiply this side by to get all of this?
H minus 2.
Good. H minus 2. Okay, you see how there's...
Why is it just, like, what about the other H plus 2?
Over here?
Yeah.
We've got that represented. We've got 2 of these and 1 of these. And we have to make sure that our LCM has all 3 of these things in it.
Okay, so
Say it again.
no, I get it.
You got it?
So then multiply H minus 2 there, like the LCM, right?
For this one.
Yeah.
What do I have to multiply this by?
Plus 2?
Yep. You see it?
Yeah.
Cassandra? Uh-huh. We have to see H plus 2 twice represented and an H minus 2 in order to get a common denominator of H plus 2 squared times H minus 2. In order to add the numerators, we have to make sure that this one has all of it and this one has all of it.
So both of you have to add, like, the denominator that you over to the LCM, right?
Yes,
Okay, so.
exactly.
That's easy.
Okay, what about this one? Okay, let's factor it though. Okay?
It will be 3 times A minus
Okay, so now what's my LCM?
2. A minus 2 times A plus.
We're still missing something.
Oh, 3.
3 times A minus 2 times A plus 2. Correct? So what would I multiply this side by, Andrew? A plus 2. And the right side? 3 times, we're going to do it this way, 3 times A minus 2. But you're right. You know, you got to have 3 represented too. Right? All of it. Doesn't this side already have a 3? And it already has an A minus 2? So all it needs is an A plus 2. And this side, all it has is A plus 2, so we have to multiply it by 3 and A minus 2 so that it gets all of this. Then I would have a common denominator of 3 times A minus 2 times A plus 2. All right, that's all 6 problems I've got for you. Let's go back and do the work. Oh, you guys are so excited. Come on. But if I would have done this from the beginning, I would have lost half of you within, I don't know, 5 minutes. Right? Okay, so let's multiply across. If I have to multiply 3 times a plus 1, let's do that. 3 times a plus 1 plus the quantity a minus 3. So when I do that, I get 3a plus 3 plus a minus 3 all over 3a. 3a plus 1a is how many a's? Positive 3 and negative 3 cancel each other out. And I have 4a over 3a. A's cancel. And my answer is 4/3.
That was not, you said these were like that.
That's the first one, Elgin. Let's make it a little more difficult. Is that better? Okay, so I need to multiply these quantities, correct? So I'm going to have to multiply b plus 1 times b plus 3. And I'm going to have to add that to the quantity of, do you want to put the b in front? I like the b in front. B times b minus 5. Stop. How do we do this? We could use a box, or we could FOIL it. I'm going to FOIL it. B times b is b squared. B times 3 is 3b. Change my color. 1 times b is b. And 1 times 3 is 3. With me so far? So far, so good? B times b is b squared. And b times negative 5 is negative 5b. And this is all going to be over b times b plus 1. All right, let's simplify. I've got a b squared and another b squared. How many b squareds do I have? 2b squared. I have a 3, let's cancel that, we're done with those. I've got a 3b, another b, and a negative 5b. What does that make total? Negative 1b. And finally, I've got a positive 3. All over b times b plus 1. One more thing I have to do with this. I need to double check to make sure what? No. It's simplified all the way. How can I make sure that this is simplified all the way? In the top, I've got 6b squared, and in the bottom, I've got negative b. Is this factorable? Is it? I don't think it is either. So therefore, I couldn't simplify this and cross-cancel, right? So we know this is our answer right here. You just have to double check, okay? Everybody okay with this so far? Okay, those of you that want to go ahead, I'll reveal all of these. How about we just finish these? We won't finish 5 and 6, and then let you do your homework. Okay, so I need to multiply these two, which is x times x plus 2. I've got a negative here that I need to remember. That negative needs to be applied to that 3. So over here it would be negative 3 times x minus 3. These don't cancel. Why can't I cancel these? Well, no, not if it was just quantities, I could. Because they're being subtracted. Just like we can't do this. We can't just cancel the 2's. It's the same thing. You can't just cancel these. There's a subtraction sign in there. Yes. Where did I get the x from? X plus 2 times x is the first one. And the second one is negative 3 times x minus 3. See that? And it's all over our common denominator. So when I FOIL, you don't have to completely FOIL this, you just have to distribute. I get x squared. I get 2x. We'll do a different color with this one. I get negative 3x and positive 9. All over x minus 3, x plus 2. What's the last thing I need to do? X squared minus x plus 9. And finally, I just need to double check that this isn't factorable. Does it factor? No. Yes. Underneath? Like these? Because I have to distribute B to everybody. Then I have to distribute 1 to everybody. That's a good question. No, that's a good question. Okay, everybody got that one so far? So that's the answer to that one. Go lastly to this one here. I don't have to multiply y minus 2 by anything, right? So it's just y minus 2. I do, however, have to multiply these by each other. And you should recognize something right away here. Anybody recognize anything? These are the difference of 2 squares right here. Isn't y minus 2 and y plus 2 the difference of 2 squares? So then wouldn't this just be y minus 2 plus, forget about this, just look at these two. If I were to do y minus 2 and y plus 2, what does that end up being? Y squared minus 4. The difference of 2 squares, right? If you didn't get that, you would just FOIL it. You see it though? They're just inverses of each other, right? All over y plus 2 squared. Let's combine like terms. I have a y squared. Thank you. I have a y squared. I have a y. And negative 2 and a negative 4 make negative 6. All over y plus 2 squared. And can this be factored? I don't think so. Negative 6y squared positive y. Yeah, it can. Anybody see it? Isn't negative 3y, oh, wrong way. Negative 3y and, 3y and negative 2y makes negative 6y. Isn't 3y minus 2y y? Let's keep factoring and see what happens. What goes in this box? No. No. What goes here? Negative 6. And what goes here and here? These two right here, right? 3y and negative 2y. Y times y. Y times 3. Negative 2. So this factors to y minus 2 and y plus 3. Does that help us out at all? No. It would help us out if one of them was y plus 2, right? But you have to do it in order to see if it will. Does that make sense? Your homework won't be as hard. Yeah. Okay, that's it, guys.